Hey guys, welcome back. Today we are doing a really short lesson on Newton's third law of motion. So we've already talked about the first and second law, and we've talked about forces. So today's really just a brush up on reviewing some of those concepts and defining Newton's third law. So let's go ahead and jump into it. So as a review, a force is a push or a pull on an object, and it's typically it is in units of newtons or in. So we have been solving for force because we do our force is equal to mass times acceleration. We've already done those calculations, so this is just a quick brush up. So there are some basic force types, right? Applied forces is when one object pushes on another. Gravitational force is when the Earth pulls objects towards it. Remember, the gravitational force on Earth is 9.8 meters per second squared. The normal force is when object surfaces are touching. We talked about normal force in our force diagrams yesterday. And then frictional forces are object surfaces are sliding or are prevented from sliding past each other. Remember, the force of friction has to be overcome in order to ensure that an object will move. So Newton's third law states that for every action force, there is an equal and opposite reaction force. So examples of this would be tug of war, trampoline, your hand hitting a table. Basically, what it's saying is that if there's a force applied, there's an equal and opposite force acting in the opposite direction. We saw that with our force diagrams yesterday. So if you have like a book resting on a table, you have the force of gravity working on it in the downward position, but you also have the force of the table that's pushing it up in the opposite direction. So that would be the normal force, okay? Some examples here. So we have a hammer that's hitting a nail. So there's a force applied in equal and opposite direction. So the hammer is applying a force to the nail in the downward direction, while the nail also applies a force upwards towards the hammer. Same for the swimmer here. She's pushing off the end of a pool in order to start swimming. She has a force that's applied on her feet in the left-hand direction from the wall, while she also applies a force to the wall itself in the right-hand direction. Okay, so for every force, there's an equal and opposite reaction. So one object will exert a force on the second object, and the second exerts a force back that is equal in strength but opposite in direction. So here with Tug of War, we're seeing that these two people, they're working on them, each other in equal and opposite directions. So an example of this would be an action force with the Earth pulls on the moon. So if you guys remember back to Earth science, your freshman year, the Earth, of course, has a gravitational pull, right? That's what keeps you grounded. It's the reason we don't all float into space. But Earth also has a gravitational pull on the moon as well. So Earth pulls on the moon. The moon is a natural satellite of Earth. It stays in orbit. And then in the reaction to that, the moon also pulls back on the Earth and causes the tides. So remember that our tides on Earth, high tides, low tides, is caused by the gravitational interaction between the Earth and the moon. Okay, so the Earth pulls on the moon and the moon pulls on the Earth. And that's it. So this is basically just a rundown of what we've already talked about because we've done force diagrams. We talked about net force, looking at normal forces and the force of gravity. We just had to define Newton's law today, and that was super, super quick to round out this unit. So you guys are good to go on to your assignment for the day, but if you have any questions, definitely let me know.